Some storms are so powerful they rip apart everything in their path. But imagine a storm that doesn't tear through clouds. It tears through reality itself. A vortex of gravity and light spinning so fast it twists the flow of time. Scientists call them space-time tornadoes. And if they exist, they could rewrite everything we think we know about physics. Welcome to Cosmic Atlas, where we explore the edge of what's possible. Today, we're diving into the mind-bending idea of space-time tornadoes, cosmic whirlpools that might form when immense masses spin so violently that space itself begins to twist. It's a theory born from Einstein's relativity, but its consequences reach into the heart of creation itself. Here's the challenge. We can't see space-time directly. Einstein told us that gravity is nothing more than curved space, and when objects spin, that curvature can drag the space around them. This is called frame dragging, and it's been confirmed around rotating black holes, known as Kerr black holes. But what happens when that dragging goes beyond rotation, when it starts to spiral? Could it create a space-time funnel, a tornado-like vortex where time itself loops and folds? For now, we can only infer. Our telescopes can capture gravitational waves and X-ray flares, but not the invisible motion of the cosmic fabric itself. To detect a space-time tornado, we'd need to witness light being twisted, time being stretched, and gravity forming a spiral no instrument yet can resolve. That's the frontier, and the mystery scientists are racing to understand. To grasp this, imagine space-time as a deep ocean. Every star, planet, or black hole is like a boat, creating ripples as it moves. When two of these cosmic ships spin close together, like merging black holes, their ripples collide, forming waves that twist instead of just expand. Physicists have even modeled this behavior mathematically. In 1949, Kurt Gödel proposed a rotating universe, a cosmos so large and slow that space-time itself swirls. In Gödel's equations, time travel becomes theoretically possible. You could ride the rotation and return to your own past. It sounds impossible, but the math fits Einstein's field equations. If the universe allows this kind of rotation, then smaller local vortices, space-time tornadoes, might also exist around extreme cosmic events. In 2021, simulations of black hole mergers produced something astonishing. After the collision, the newly formed black hole didn't simply spin. It whirled the space around it, creating gravitational waves that looked like a spiral storm. Physicists described it as a twisting cone of space-time, almost identical to the shape of an earthly tornado. At the same time, studies of magnetars, neutron stars with magnetic fields 1 trillion times stronger than Earth's, revealed similar twisting effects. Their magnetic poles appear to drag local space-time into tight curls. If confirmed, these could be the first glimpses of real-world space-time tornadoes, storms of magnetism, gravity, and light coiling into one impossible structure. Such discoveries hint at something profound, that the universe doesn't just bend, it spins. Let's zoom in deeper, to the quantum scale. Quantum field theory says the vacuum isn't empty. It seethes with energy and fleeting particles. If space-time behaves like a fluid, then these fluctuations could produce microscopic whirlpools, quantum vortices. Physicist John Wheeler once described the universe as quantum foam, a frothing sea of tiny distortions. If that foam can twist, each bubble might momentarily become a miniature tornado of time, 1 billion times smaller than an atom, yet echoing the same geometry as a spinning galaxy. This idea bridges the vast and the minute, suggesting that cosmic storms may exist at every scale of reality. Here's where things get revolutionary. In certain models of quantum gravity, space-time behaves like a superfluid, smooth, continuous, but capable of forming vortices when stirred. Physicists like Ginzburg and Mazur propose that under extreme conditions, such as inside rotating black holes, this superfluid space could twist into long, stable filaments. Each filament would be a space-time tornado, channeling energy and information between regions of the universe. And when those filaments stretch beyond a critical limit, they might rupture the fabric itself, creating what we call wormholes. In that sense, wormholes aren't portals. They're the breakaway funnels of colossal space-time storms. Every black hole could be a hurricane's eye, calm at the center, chaotic at the edge. Do we have evidence for these cosmic twisters? Perhaps. When the Event Horizon Telescope imaged the black hole in the galaxy M87, light around it appeared uneven, brighter on one side, dimmer on the other. That asymmetry suggested the surrounding space was spinning, pulling light in one direction. It wasn't proof of a vortex, but it matched the predictions of space-time rotation. Meanwhile, detectors like LIGO have recorded faint aftertremors, spiraling gravitational echoes following black hole mergers. Some physicists think these are remnants of vortex motion, like the final winds of a dying tornado. If true, it would mean the cosmos is constantly generating and dissolving storms in the invisible medium of existence. Now, imagine scaling up, way up. Some astronomers have found entire galactic clusters rotating in the same direction, as though following a vast cosmic current. Could the universe itself be caught in a giant slow-motion tornado? A swirl of billions of galaxies revolving around an unseen axis? If that's real, it might explain strange asymmetries in the cosmic microwave background, subtle temperature patterns that hint the early universe already had a preferred spin. Instead of a calm, expanding balloon, the cosmos could be a whirling gyroscope, twisting as it grows. In that view, time isn't a straight line. It's a spiral, and everything, from atoms to galaxies, moves along that endless curve. So, what are space-time tornadoes? They might be gravitational storms, quantum vortices, or even the building blocks of new universes. Whatever they are, they remind us of a humbling truth. The universe is not static. It's alive with motion, turbulence, and infinite possibility. We're not just drifting through space. We're spinning inside the grandest storm of all. What do you think? Are space-time tornadoes real, waiting to be discovered, or just the wild dream of physics on the edge? Share your thoughts in the comments, and if you love exploring cosmic mysteries, make sure to subscribe and check out our next video. When black holes collide, the sound of space-time itself.